Awesome. I cannot see anybody in here, so I'm going to assume that this is the completely packed theater. Quick little scale of, well, normally I would ask people to raise their hands. I guess round of applause if you like fun apps. Okay, so I can check off that I got a round of applause as I took my presentation. But you also highlighted a great thing. Everyone likes apps that are actually fun. No one really likes a boring app. Who likes an app that is slow? Exactly, it is lame. No one wants one of those. Everyone wants things that are fun and wants things that are fast. But if you go to any performance review, people are going to automatically point out certain aspects of an app that are slow, not performant, and typically these are the fun things that we want to add. These are the animations, the scaling, the box shadows, all the cool stuff that we want to add. And I find that a shame because I like to think that we can have nice things. We can have great performance with also the flashiness, the finesse, the last 10% that's going to make our app stand out. So my name is Mike Hartington. I'm a developer at a company called Ionic. You can find me everywhere on Twitter as mhartington, and I want to talk about the secret to fast performance. We're going to be looking at how we can actually build stuff that is fast, but also really cool. So let's define performance. If you ask 10 developers what is performance, you're probably going to get 10 different answers because performance is a very wide topic. You can be talking about how fast does your JavaScript get parsed? How fast does your web apps take to download from the internet? There's various different ways that we can use to categorize performance and different ways that we can look and say, is this performant in X, Y, and Z categories? Most of these kind of fall into places that are outside of our responsibility or our control. We're not really going to look at load time because hopefully your network providers and your hosting providers can ship your web app to your users pretty fast. If it's not, maybe check for a different provider. We're not going to look at how fast does your app start up because chances are that is a framework problem and not an application problem in some regards. You could be writing a very slow app, but your framework should also be guiding you to the best path possible to ship a fast app by default. We're going to look at the parts that make the app fun and focus on the UX aspect, but doing so in a way that is not going to introduce any bottlenecks to our app. We don't want to go ahead and spend all this time and energy adding cool features that are just going to make the app slow, because what's worse than a boring app? An app that's slow. Doesn't matter how many shadows, how many animations you have in it. If it's slow, it might as well not work at all. Now, to start off, this stuff is not easy. If you go talk to a designer who is very good at designing web apps or mock-ups, chances are that the things that they design in their platform of choice, Figma, Sketch, what have you, not often is it easily translatable to the web. These are just limitations of the platform, but also it wouldn't be smart to include all these features in your web app because it just doesn't translate well. The things that they often try to go to the nines with are animations. How many animations can we add in our app? Can we animate everything? Can we put like a little floating cursor inside of our app so that way as a user is scrolling around, they see glittery stars? You could, but why? Can you include state changes or updates to your app that are going to run constantly and be 60 frames per second or 60 FIPS? Making sure that your app includes all that and does it, all while maintaining that performance and is not blocking the main thread. These are things that we're going to look at, but state the obvious. It's not easy to do this. If you don't know the tricks and tips on how to get this done right, you're probably going to feel like it's not possible. I am here to show you, though, that it is possible. Now, if you don't know these tricks, it can often lead to apps that either just don't have these features or they implement them poorly. And either one of those extremes are going to lead to the same kind of feedback from users in that the app just doesn't feel native. And that keyword of doesn't feel native is pretty interesting because native apps these days have trained users so well that they should expect something that is fast and performant, but also interesting. Why do you go onto Twitter to click a like on a tweet? Not just because you actually like it, but sometimes it's because you want to see the animation when the heart explodes into a little bit of confetti and you get the red heart that's showing that you liked it. It's a state change. It's not changing the functionality of what you are doing, but it's that little bit of something that makes the app feel fun. It's going to keep bringing you back. So native provides these features kind of out of the box, so that way devs can just figure out what do I want to do, and then native will try to figure out the rest on how to make sure that this is going to stay fast. Native also gives you the primitives to be able to do things like smooth scrolling, performant gesture interactions, all the things that we as web developers want to add. They just get it out of the box. And oftentimes it's going to stay fast regardless of are they using the latest phone or the oldest phone. So let's take a look at an app right here that kind of proves this. This is Apple Music. Anyone use Apple Music? No? Thanks, Kim. Most people are probably fans of Spotify, but I can tell you that Apple Music does have some cool things in here, and it's a pretty fun app, in my opinion. So some of the things that we're going to see in here, when we go and we open up the now playing, we have a scaling effect. As you play and pause the song, we're going to get some feedback into the state of what's happening. When we go to the next song, we're going to get some feedback that, hey, different artwork, we should have a different color background. And then as we open and close the up next or the queue of songs that we have, we should have some feedback saying, hey, new elements or new content is coming into view. Let's not just throw a jarring layout change, let's animate that. This to me is a really good example of something that goes beyond hello world and asks you as a developer to think about the stuff that you're going to do. It also helps that none of those features are going to break the app if we were to remove them, but it wouldn't be the same app, in my opinion. So let's rebuild Apple Music with the web. I don't know about anyone here. I've had like 2 years worth of free time, so I've been able to research this pretty extensively, and I want to share the results of this research. We're breaking it down into 3 different categories of being able to figure out how do we animate the right stuff, how do we adapt to unknown or complex layout changes, and how do we do that? How do we do that darn background color change? Because that is so cool, and I want to be able to do it. For context, the app that we're going to be seeing that I built throughout this entire demo is an app built with Ionic and Angular. You do not need to use Ionic and Angular. You could use whatever UI library you're comfortable with and whatever JavaScript framework you're comfortable with, or no framework at all if that's how you want to roll. Everything that we're going to see is applicable to React, Vue, Svelte. The principles are going to apply to all of them. So remember the principles, not the actual code samples. So let's dive into the first one of animating the right things, and we're going to try to recreate that play-pause state. Start very, very simple. It is a play-pause where the album art scales up, and we create a sense of elevation. And just in case you forgot, here's what we have for the video. We're pausing it. The album art shrinks, but you also notice there's a very, very slight shadow that appears when the album is larger. So it has that sense of elevation. It feels like it's up from the surface. And I think that shadow is going to be key to getting this sense of elevation. So, like any good developer, I go to Google and I end up on Google Material Design. And I think, let's just copy and paste some random code I found on the internet, throw it in my app, and that's it, right? We're done. And it's going to go south real fast, but I'm not trying to make a dig at material design, because they actually have really good documentation on this stuff. They have a whole system where they say, all right, you are at 1 point of elevation to 8 points of elevation, with 8 being the highest from the surface. So if you do need this is actually a really valuable resource. Please go look at it. But we're going to see how this falls apart when you try to do something more fun. So I copy and paste that code, throw it into my app. It might not seem like it's doing anything because of the screen share, but I promise you there is a shadow there. If you can see it, great. If you can't, don't worry, we'll see it in a more complete demo. Now this looks great. Thought about shipping it, but then I remembered box shadows are terrible. Box shadows, drop shadows, whatever the CSS naming is, it's so confusing. They're terrible, and they're bad for performance. Now think of it like this. The browser has several steps that it has to perform to show you a web page. It gets your HTML, it gets your CSS. It goes, okay, I'm going to lay out all the DOM, then I'm going to apply the styles, and then I'm going to do the rest of the whole process. That applying the styles part, though, is really complicated, especially when you include a shadow, because as your shadow kind of feathers out from the concentrated part next to your element to the parts that are further out, it now has to calculate, okay, I'm at this point, what is the combined color of my shadow plus the background color? Okay, I'm at this point. Do the same operations over and over. So it has to calculate not only just the shadow, but the computed value of that shadow plus whatever things that are behind it. That's really slow. If you throw up a list of 50 divs with a box shadow on it, and then you try to scroll up and down, that's going to be really, really slow, because now we're having to move those shadows. When we throw in animation, which could be happening multiple times per millisecond, we're now having to do so many recalculations to account for the fact that I am at this point in my animation, okay, I get the colors, okay, I'm at this point of the animation, do this, do that. It's a lot of moving parts, and the browser is doing extra work to figure out these colors. So you're going to be doing a lot more work. There's going to be a lot of recalculation in the browser. You're actually going to see a CPU spike, which I thought was really interesting, and this could have a negative impact on your user's battery. Trying it on a desktop, it's not going to be the same. Trying it on an iPhone might not necessarily be the same. Try it on your average Android device. It's going to be noticeably slower. Good news is that the browser can actually show us the impact of this. So there's this really cool feature in DevTools called paint flashing. Basically, anytime you want to see a repaint inside of your app, you can toggle this. You can see all the affected areas that are being influenced by that box shadow. So as we scale it up, we can see that not only are we repainting where the shadow is, but there's a secondary box. I'm not quite sure where that comes from, but it means that I'm trying to repaint that. And while this is just a single element, imagine adding more features and more things here. If we're starting off with this flaky of a UI, it's just going to go downhill real quick. So let's take a look at this in the browser. I have the app running right here, just to prove that I actually did build it. And here is the shadow. I just colored it red so that way everyone can see it. Let's go ahead and look at the tools that we're going to have here. So inside of Chrome, Edge, Brave, Firefox, and Safari, they all have this option. We're going to look at it in Edge because it's got some good profiling tools here. And we're just going to click paint flashing. So now we can see everywhere in there is being affected by our box shadow. Cool, now let's measure. And we're going to hope that people aren't going to have this bad of a device, but we're going to go for a 6x slowdown because we want to be able to hope for the best, but plan for the worst. You know, the nice pessimistic New England outlook on life. Now let's go to our performance monitoring. CPU spiking, we were at 30, 33%, so roughly 30 to 35% of an increase or a CPU usage. Style recalculations, this is actually really low. Last time I was seeing like 120 recalculations per minute, but that's still not really good. This is really bad. If we were to let this run and I did not have my laptop charged in, it would eventually crash my computer and drain the battery. So what can we do instead of that to make our app fast? So let's go open up the UI for this, or the CSS for this. This is the styles that we are using to create that box shadow. We just have the element. We're using keyframe animations because no real reason. And then I have the different levels of shadow for 0 to 100%, essentially give me the bare minimum shadow. 50% go all the way. I want to see as much shadow as possible. So this is terrible for performance, terrible for CPU usage, bad for your users. Erase all of this from your memory. This is not things that you should be doing. There are other options though. So let's get rid of all of this, and we are going to uncomment this. So what is a shadow if not another element that we're adding this? And browsers actually allow you to add pseudo elements in your own styles. So what if we were to mimic this using a pseudo element, width and height 100%, background colors, again, we're going to stick with red just so it's visible. We'll do some basic positioning, some border radius. We'll add a blur. And then instead of using different tactics for trying to create the illusion, we're just going to use transform and scale 3D. Scale 3D is going to allow us to mimic a box shadow change, but it's going to be much more performant. Down here in the keyframes, we're going to just change between 0.9 and translate to 3D. And then we're going to do 1.05 for the scale. And we're just going to move it down a little bit because, you know, lighting is weird when you try to create shadows. You need to offset it a little bit just so it looks more realistic. And all these values, I just I tried and said, oh, that looks good. Let's save this. And because I know I didn't remember to disable this, let's go to performance. Let's not do a 6x slowdown for now. Let's just reload real quick to make sure it's going to work great. Awesome. So make sure we'll do the same steps as before. We'll enable paint flashing. We will do the performance monitoring, 6x slowdown, and performance monitoring. There we go. We are getting a similar effect, maybe not as intense because I didn't really scale it up that well. CPU usage is super low. And the most important part is that our style recalculations are not happening. The browser is able to handle this by putting it on its own layer and not having to introduce any repainting steps, because this is separate from how the styles get interpolated by the browser. So you could swap out the pseudo element for another div if you are using a framework or something like web components where you can isolate this in its own content. If you want to stick with pseudo elements, you can make a class that you just apply to any element that you want to get the box shadow, and make sure that it's going to be essentially jank-free UI changes. So just in case the demo didn't work, had a recording. always, like I said, plan B. We have our styles again. We went from the box shadows and using keyframe animations for this to using pseudo element, still using the keyframe animations. Now, I will point out it is a difference between 16 lines of code and 21 lines of code. Not that lines of code are any, should be really taken with any serious, it's not going to make or break the bank, what I'm trying to say. This is going to be essentially the same impact in a code base. And like I said, if you wanted to include this as a class that you just randomly slap on any element, you could do this. Again, another demo just to make sure that the first one was going to work. You can see the styles are, the shadow is still playing and it still looks smooth and performant. So we can animate things on the web, but we're just going to be a little bit smarter about how we do it. Maybe don't use a box shadow. Please don't use a box shadow. If you leave this talk with anything, do not use a box shadow. Create your own shadows if you need to. It's essentially what the CSS rule is doing, except this is going to be far more performant. So let's go into the next part, and that is dynamic and unknown animations. These are things that, for the life of me, I almost gave up on because animations in general are not my strong suit, especially when you have complex layout changes. I thought about giving up on this multiple times because this right here, as simple as it could be, I mean, you essentially have an element that's moving over to a different side, and then you're fading in and scaling the player queue. Not a complex animation. There's literally two parts moving. But this layout change is really difficult because once you animate one thing, you now need to account for the incoming element. Once you try to remove something out from the DOM, your animation values are going to get messed up, and they're going to feel like it's not going to be possible to do this. Until I stumbled on some articles from people in the web perf world and the animation world about Flip. Round of applause. Anyone hear of Flip before? Thank you, Alex. Flip is an acronym because what is a web term without it being an acronym? Where we say first, last, invert, and play. It's a really simple process. What we end up doing is we have an element in space, somewhere in the DOM. We're going to grab a snapshot of that location, get the width, height, X and Y layout of it. Then we're going to cause a layout change. This could be adding more DOM nodes, doing a layout change via CSS classes, and we're completely going from like display block to grid. And we're going to get that snapshot of the element at its final position. Now with this, we essentially have everything we need to perform an animation. We essentially want to create the illusion that our element always animated. But really what we're doing is saying, here's the ending position, here's the starting position, figure out the difference, subtraction essentially, from those two positions, and we're going to create a web animation with that. Once we have that web animation and we know the path that it's going to take, we simply play it and we make it seem like this element was always going to transition. It's a really nice little hack to do animations when you're just not quite sure how things are going to work out. The math for it is not complex. It's basic addition and subtraction. Sometimes you can get division in there if you want to make your animation spicy, but you don't really need to worry about that. So I'm going to focus on this one because the animation I wrote, I decided to go all out for it, but this is the only important stuff that we need to worry about. We essentially have this animation over here where we are grabbing the two elements we want to animate. My two elements are always going to be in the DOM. One is just going to be set to display none. So I have the now playing card, essentially the album artwork and music controls, and then I have the player queue that's going to animate in. And then I have this function called getRec, and there's a real fun name for it. The method that you actually want to call is getClientBoundingRec. Now say that 5 times fast, and you'll understand why I called it getRec. Plus, getClientBoundingRec can go get wrecked. It is actually a pretty big impact to do this, so we want to make sure that we are minimizing the amount of times we call this method. So we call it first when we want to get the initial position. We toggle our layout, cause a layout shift, and then we call it again, and then we should never call this again for the animation. We should make sure that we minimize that, and at least do it higher up the chain so we have all the reads in one place. Good code hygiene. Also make sure that we know where everything's happening. Now with these two positions got, we can go ahead, we can do our math here, and we can say, hey, let's get the delta between the start and the end, and essentially say, okay, for the player album artwork, the player controls, it's a difference of get the before value, the left, and the right, subtract it. Top for the before and after, subtract them. And that's all we need to do for that one. The player queue, we're going to do a little bit more math here because it's JavaScript and we can be fancy here. We're essentially saying we're going to fade in this element between 0.8 and 1 or 1 and 0.8 because we want to do our scaling. And then we also want to figure out the opacity changes here. So we're just going to do these two values. Could simplify it if we wanted to, but we don't need to. Once we have this, we're going to create our animation. And this is using a function inside of Ionic called create animation. You don't need to use Ionic, as I said. You could apply this with web animations or GreenSock if that is something that you want to do. You can say, all right, we're going to create an animation. We're going to give it the element. And then we're going to use this method called from_to, which will do a transform, and then we're going to scale it from this initial value, which could either be 0.8 or 1, and we're going to do it to the final value, which could either be 1 or 0.8. So we have a nice little scale-on effect. Either it's going to scale in from 0.8 to 1 or vice versa. Then we'll do the same thing for opacity, and it's going to either be 0 to 1 or 1 to 0. Pretty simple. And then we push that onto the parent animation chain, and everything's done with this one. The next one's even easier because all we're doing is just translating this element from the DOM. We'll go ahead, we'll get the element. We're going to do something that I think is, I don't know if this is possible with web animations, but I know we have a nice little hook for it where we can add some styles before we actually animate. And this is just going to say, hey, make sure that the animation center or origin is going to be in the top left. There's some reasons for that, but they're not really applicable here. Once we have that done, we can say transform, and we're going to translate 3D. Again, we're using all these 3D transforms because this is going to be performant, and the browser is going to know that this means I should put this on a layer. After that's done, we will get rid of the transform origin and push the animation onto the parent animation chain. Once we have that, we end up getting something like this. Now, the animation is pretty basic. All we do is we just animate the card to the left, and then we scale in that queue. I don't have any animation logic because I am a lazy developer to handle when the player queue is being hidden, so you'll notice it just jumps away. I'm sorry. But the other parts work really well and are really fast. The good thing here is that our animation is now set up to be independent of orientation. So if for some reason we decide to rotate our UI, we could just add a few little checks to say, hey, are we in landscape or portrait? Animate these things too. And the same animation can be applied here. So instead of having to animate just the album artwork, we're going to do the artwork and the title and change that positioning. Everything else still works the same way. So our animations become a lot easier to reason about because we are just letting the browser tell us where we should be animating from. It's a really, really nice hack. Like I said, this is using Ionic's own animation, so you do not need to use Ionic or our own animation library for this. It's applicable to web animations, GreenSock, and in fact, GreenSock actually has a plugin that you can use for this called Flip. I believe they made it free a month or two ago. But essentially all you do is you just say, hey, register this Flip plugin, add it, and anytime you do animations with GreenSock, it'll automatically handle all this layout change, and it's going to use that flip principle behind the scenes. So this is really good. It handles things when you remove an element from the DOM, it'll automatically know, okay, well now we have to account for that. If you do what I did where you set display none, it'll automatically account for that and put it in part of its animation process. So this is really, really great. If you want to take anything else, box shadows are bad, maybe check out GreenSock. Okay, so we can animate unknown things, we can animate the right things. What about this reactive background that I think is so cool? Well, all we're really trying to do is just get the color from whatever song is playing, and we're going to try to look at that artwork to figure out what the color is. Should be easy. Has anyone ever done this before? Well, actually, one person did, and we're going to look at their work. But here is the native implementation, just to make sure we're all aware of what we're doing. It's really, really nice effect. I'm very jealous that they get to do this for free. We're going to have to do some work to replicate this. And this is not the first time I've done it. There is a library, but I made it, I think, better and faster. And the library that we're going to be looking at is Color Thief. Color Thief is a browser and node-based package that will go ahead, you feed an image, could be an image source, image from buffer, image from URL. It will go ahead and it will try to get that image and analyze it and determine all the colors from it. So here we have a picture of carrots, celery, snacks, but it's on a blue plate, and that blue plate is pretty dominating for the entire photo. So they rightfully so say that, hey, that is our dominant color, or that is the main color from this photo. Now there are other colors that are also in this photo that are maybe not as common as the blue, so we'll give you an array of colors afterwards that are going to make up the palette of this image. This is something that Android recently added with Material U, where you can actually update the colors, and the same work is being applied here. So Color Thief is really great. It's kind of old, hasn't been updated in a little bit, still works, but it's using a lot of older styled programming. We're going to try to make this faster, and we're going to use, obviously this is with Angular, so I'm using a directive in Angular, which is essentially just a modifier on an element, and web workers, because web workers are something that not everyone actually uses or knows about. We're going to attach it to an image, and anytime that image updates, we're going to say, okay, go ahead, process this image, and emit an event whenever you're done, and the web worker is going to go ahead and just crunch all those numbers and figure out the calculations in the background. So let's look at the code for this. It's a little bit more intimidating. I won't show you the worker code unless you really want to see it, because it is basically just a whole bunch of math that I copied and pasted from Color Thief. I'm not that very good at math, so I don't feel like I could represent it pretty well, but I can represent this stuff pretty well because I adapted it into my own directive. So what we have here is this onChange hook, where anytime the image source value changes, we're going through and we're just saying, all right, is this the first time that we're doing this? If so, don't really do any of the operations. Or if we are doing this from again and we have a new image, let's go ahead and compare it just for safe reasons, because sometimes APIs return files with different query params, and those will actually require you to do multiple calculations. Whatever, doesn't matter. We're essentially saying, go ahead and do this animation if the images that are coming in are different, and we're going to say get palette from URL. This method could be whatever we want. All that it's going to do is just download that image and store it in a image object in JavaScript, which is really what we wanted. Once we have that, we can go to this method called getPalette, which is going to go ahead and do some defaults for us. It's going to create a canvas element in the background. It's going to place that image in the canvas. And once we have that image in the canvas, we essentially have all the data we need, because we can get all the pixels, the count of the pixels, like how many are there, and then we can just say, pass this to our worker and figure out what the actual dominant color here. And you know what? Let's go ahead and just look at the worker. So inside of workers, we have events. We wait until we get some data, and that's from this message event. And we have all of the variables that we are getting in here. Now, once we have all of those variables, we are essentially just going to loop over every single color and then every single pixel. And then we're going to create a multi-dimensional array of every single pixel in this image. So every single entry is going to be an array of RGB, 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 keep going on down. Apparently also alpha in there because I decided to use that, but I don't really use it anywhere. Yeah, I don't even push it onto the array. That's fun. Once we have that, though, we can use this quantize. And this is really all of the logic that Color Thief uses. This is all just comparing all of the different colors. There's a lot going on in here. I'm not 100% sure what it's doing or how it's doing. I'm not that smart of a developer. This person is much smarter and actually created all of this stuff that I could benefit from. So yay, open source. Once the worker has finished out processing all this, it'll go ahead and it will return that data, and then we can do whatever we want with it. So now we have an array coming back of all the dominant colors here. We'll do some quick little cleanup because we now have a loose canvas hanging out in our web app, and we're not making web apps with canvas, so we don't need it anymore. Once we have that, we can just say emit the color on our event, and then, hey, we're done. We now have something that works like this. It's really nice when you go from a light color album art to a dark color album art because the change is very drastic, and so it actually looks even cooler than it really is. But all we do is here is every time we are going to a new song, we're just emitting an event, capturing it up higher up the DOM chain, and then we're animating a background color change. Very, very simple in principle. It's that worker and that process of using the worker that is making this fast and non-blocking. All the songs are still playing. I could play and pause to my heart's content, and I could skip all the songs kind of, constantly tapping next and next, and the worker's just going to keep chugging along and it's still going to work well. So this is really great. So I have a QR code if you would like to actually see the app because we're going to demo it in real life. If you don't have your phone or you don't want to look at it right now, you could go to the URL startrack-ng.web.app. There was a long-running joke that the original purpose of this app was just to star random songs. So I was going to star this track and I was going to star this track. It has long since grown out of that scope and is now something a little bit more ambitious. Let's actually look at the phone over here. Oh, that is huge. All right, we'll just go to full screen. So this is my phone. Yeah, okay. This is actually pulling data from Apple Music. So if you were to go to Apple Music right now, you'll see similar albums and playlists. But we're going to go to our Sleep Sound playlist. The UI here, again, is built with Ionic. Doesn't really matter. We're going to hit play. And here we have our app running, incredibly smooth. We can open up the queue. We have all of that looking really great. We'll see the thing that, nice subtle change, more drastic. And it works so smooth. We could put this up on an older Android device. I have a Nexus 5A, I think it is, 5A, whatever one when Google decided to put out two phones at the same time. I have one of the lower end Nexus devices and I run this on my, as a testing device, and this runs smooth on that all the time. Again, as I said in the worker, I could constantly hit next, and it's still going to process all of the upcoming colors. It might not process this right now because Wi-Fi is non-existent and cell service is barely existent. I'm surprised it operated this far, so we're going to call that demo at this point. Oh, here we go. Okay, now it wants to work. But it still illustrates my point. It just rapidly changed through all those albums, and there was zero jank as the worker was chugging along. So this is really fun. We'll pause real quick. Go back to the slides. So again, if you want to check it out and play it around, you don't need a login or anything. There is a login if you actually want to, but you could just browse and get 30-second kind of previews of everything. Really just a fun app to work with. So let's kind of wrap it up real quick. We can have nice things. I think I proved that. I hope I proved that. I hope you take that away from here, is that we can actually have really cool apps that, one, accomplish really cool tasks, but also have an extra little effort put into it to seem engaging, fun, and still remain performant. Figure out how to be smart about what elements you want to animate, but also what CSS properties and what kind of UIs are you building. Can you take shortcuts that are going to pay off in the long run? Flip animations, use them. If you're not, just use them. They're great. Web workers, also just use web workers. Find every opportunity that you can to create a web worker, and you will see how beneficial they are to your app. Only caveat is that you can't do any DOM operations in a worker. So if you're just doing a bunch of number crunching, worker's gonna help you out there. They are supported in every web framework, I think, yeah. Angular just has a nice little way where it'll automatically generate one for you. React will ask you to download a package and install it, and I don't know what Vue has. But they are fun and they are great. So if you have any questions, I'm happy to take them, but thank you so much for hanging out for almost an hour, and I hope you enjoyed it. Thanks. Yes.
Do you have any information on box shadows bad? Gradients?
So box shadows are bad. What about gradients? Gradients are okay for the most part. There is some hesitation to use them because you cannot transition between two different gradients. So if you have a gradient where it's like 50% red, 50% blue with the different steps, if you want to change any of those colors, the browser is just going to do a change. It's not going to gently animate them through it. You could use a canvas instead, and then you're programmatically creating the animation itself. It's not ideal, it's more work, so I tend to avoid them. Cool, no problem. Yes?
In any of your development, have you noticed performance hit when nesting elements tag within tag within tag versus lifting them up so that they're all siblings, and then maybe changing position only with CSS?
So the question is there a performance impact on element nesting depth versus, yeah. There is. More browsers are getting better at this, so it's less of an issue, but it's more of a best practice to try to keep your DOM as slim as possible. So that way the browsers can perform updates and parse it faster. So in this case, I would try to not nest things so deeply. If you are using web components, though, when you have something in there and you're using shadow DOM and slot layouts, you can kind of work around this because you essentially create the parent element and then all these sub-elements that can be laid out using slots. And then because it's in a shadow DOM, it does not necessarily impact the overall DOM structure. So when the browser looks at it, it just sees parent element, child element, child element. But behind the scenes, you have a little bit more content inside of the web component that is handling the layout positions and making sure things are in the proper order. So it depends.
In
Mm-hmm.
At this stage of my career, when you come from doing this stuff in the late 90s, and you're like, oh, you sometimes fall into that nesting pattern quickly because you're making an element and what goes inside that element, so you just start nesting.
Right.
So when you mentioned the appearance of the shadow, that's how we started to change our thinking. That, okay, if we just look at this, how can we unnest, get the performance gain,
Mm-hmm.
benefit, and then keep the appearance of what we were going after? So when you were talking like that, I just was curious if you faced this thing.
Not necessarily. In my case, did I face any of the same performance nesting issues? No. When I had the pseudo element in there, it was essentially, performance hit free. There was no real impact on it. But it's also worth noting that I'm not nesting so deep in there that I have 40 elements in one single parent container as my bottleneck. I have an image, an after, and that's it. The overall structure on that DOM is relatively flat outside of some parent layout. Like, I'm not doing a whole lot in here, and like if we look at the modal itself, you can see that shadow root, which has all of the private elements for our web component. All we have when the browser parses it is ion modal, and then the actual modal content, and then things become a little bit slimmer there. So it can work out pretty well. Cool, no problem. Any other questions? You can come up over here, because if you have a question over there, I have a giant light in my eye, and I'm not going to be able to see it, but you have a question right up front.
Is it true then that when you use like the 3D flavors and CSS like scale and transform, that it's telling that you use the hardware accelerators to graphics accelerators for that?
Yes, so is it true that when you use 3D transforms, 3D, any transform, it will do a hardware accelerator? Yes. So when you go ahead and you look at it, you can actually see this is using the 3D view inside of DevTools. We can kind of see all of the different elements here, and controls are a little wonky, but you can see there's one in here that is animating and like scaling in size. If you can see it right next to the little slider. Let me move this over more. Oh no. Oh no. This is terrible. We can just zoom in. But you can see like that element that is scaling in and out, that is our shadow on its own layer being hardware accelerated, which is why the performance hack works. If we were to have a box shadow, it's being all done basically through software and as it's painting. So yes, 3D transforms are great, but don't try to do 3D transforms for everything. There's also a CSS property called will change, which is a kind of say what you mean. If you are going to change an element at some point in time, you can tell the browser, hey, this element's going to change opacity at some point. Promote it to its layer early versus just in time. So take a look at that. CSS will change. Again, don't will change everything because that just defeats the purpose. Any other questions? Okay, thank you so much, everyone.